All right, so we're going to take a look at Chapter Round Target 2013, 7 and 8. The dreaded 7 and 8. All right, so a circular spinner has 7 sections of equal size, each of which is colored either blue or red. The 2 colorings are considered the same if one can be rotated to yield the other, and that makes sense. On how many ways can the spinner be colored? Oh boy, this sounds like fun. All right, so let's get the easy stuff out. Obviously, if I color it all red, that's 7 sections of red, 0 sections of blue. And obviously, I can flip this, can't I? 7 and 0. So I'm only going to worry about the reds right now and then see how it goes. So this is if I have one section. In other words, the whole thing is one color. Well, what about 2 sections? All right, for 2 sections, I could do 6 red, 1 blue, 5 and 2, 4 and 3. But remember, I want to be able to flip it, right? If I go 3 and 4, then all of a sudden that's the same as when I flip it. And I want to be efficient because I only have 6 minutes to do these 2 problems. Let me tell you, the second one is brutal. All right, so that gives me 3 different ways of doing it. All right, now the next section. All right, so now the next question, and this is going to take a little bit of explaining to do. Now, I can have 1 full section, I can have 2 sections, I can't have 3 sections, and here's why. So I can come up with numbers that add up to 7. I can go 4 plus 2 plus 1. So this has 3 sections. But let's see what happens in practice when I do that. So 4 sections of red. So that's 4 sections of red. Then 2 sections of blue. And then 1 more section of red. Uh-oh. All of a sudden, this 1 is merging with this section, and now we're back to this 5 and 2 situation. So because of this, any odd number of things in a particular color in a row will not work because this 1 will be adjacent to this 4, making one big group of color. So I can't have 3 different sections of colors here. But I can have anything that is even. So I can have 2, I can have 4, and I can have 6 different sections. But I can't have 3 or 5. I can have 1 because it's just one whole, and there's nothing, it doesn't merge with anything else. So how can I have 4 different things combined? Well, I can have 1 plus 1 plus 1 plus 4. I can have 1 plus 1 plus 2 plus 3. And I have a little too many pluses. That should be 1. I could also have 1 plus 3 plus 2 plus 1. And I could also have 1 plus 2 plus 3 plus 1. Those would all be different situations. So right now I have 1, 2, 3, 4, 5, 6, 7, 8. Well, are there any that I'm missing? I could also have 1 plus 2 plus 2 plus 2. So there are 1, 2, 3, 4, 5 ways I can have 4 sections. there are 3 ways that I can have 2 sections. There's 1 way I can have 1 section. Well, what about 6 sections? Can I get 6 sections in here? And I bet I can. For my 6, I can have 1 plus, my goodness. For 6 sections, I can have 1 plus 1 plus 1 plus 1 plus 1, 2, 3, 4, 5 plus 2, 7. So that means I have a total of 10 different ways of organizing this that are unique. But that is only dealing with one color, having the reds in one color. I can flip it and have it with the blue as well. So if there are 10 different ways with the reds, there have to be 10 different ways to do the same thing with the blues. 10 plus 10 is 20. All right, the last problem, which quite frankly, there's a quick way and a not so quick way. The quick way is to say, all right, so I know that this distance is 5. This distance is 5. This is an isosceles right triangle, so that means this whole distance is 5 root 2. 5 root 2 squared, 5 root 2 times 5 root 2 is 50. Okay, so this area is 50. Now, if I look here, I can use the pencil lead method. And the pencil lead method, if you don't know, is you count the number of clicks that it takes to cover a distance. And since all of the problems are to scale because they're computer generated, sometimes you can get the answer. And oops. And right now, I'm noticing that there are, in fact, 5 different, this length is 5, or 1/5 the length of the square. So 1/5 of 5 root 2 is root 2. Root 2 squared is 2. 2 plus 2 plus 2 plus 2 is 8. So the answer is 58. Now, that's not going to really feel good for those of you who are really wanting a good explanation. So here we go with the good explanation. Remember, this is 50. We'll add that in the end. All right. So the distance from here to this corner is still 5. And I need a right triangle because I know Pythagoras and this theorem, they work out pretty well. So this side length here is 5 root 2, which we just learned, which means this distance from here to here has to be half of that, so that is 2.5 times root 2. I don't know this distance, I don't know this distance, but I do know that this distance is half this distance. So if I call this x, then this distance is 2x. All right, using Pythagoras, here we come. So we know that a squared plus b squared is equal to c squared, and this is going to get heinous. A squared is going to be x, that's easy, plus now b squared, here's where it gets tough. B squared is 2x plus 2.5 times root 2. And finally, c is 25. B squared, sorry, 25, 5 times 5 is 25, right? So now this is where things get really kind of difficult. So this squared means 2x plus 2.5 root 2 times itself, 2x plus 2.5 root 2. All right, so 2x times 2x is 4x squared. 2x times this is going to be 5x root 2. This times this again is 5x. Yes, oh yes we do. I can be done with this and then I can call in the lift. And then this times this, root 2 times root 2 is 6.25. Sorry, root 2 times root 2 is 2. 2.5 times 2.5 is 6.25. 6.25 times 2 is 12.5. So I can add this together and I get 4x squared plus 10x root 2 plus 12.5. All right, and we still have this x squared, so that, and we're still equal to 25. So we get, add those together, so we get 5x squared plus 10x root 2 times x. And I'm going to do that for a reason. And I'm going to subtract my 25 to get it over here. So we get minus 12.5 is equal to 0. Now, I'm not going to factor that. I'm not going to be able to. So that means we are stuck with negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug in the numbers. Negative b, so we have negative 10 root 2 plus or minus the square root of b squared. So 10 root squared is 100, root 2 squared is root 2. So that's 200 minus 4 times 5 times c, which is negative 12.5, all over 2a. So that is 2 times 5, which is 10. So 5 times 4 is 20. 20 times 12.5 is 200. So we get square root of a negative times a negative is a positive. So we get 250 plus 200, so that is 450 plus or minus, and we have 10 root 2, and that's over 10. Ugh. All right, so then we don't care about simplest radical form, so I'm just going to go ahead and do this. So 2 square root times 10, so we get negative 14 plus or 0.1 plus or minus, and let's do the square, 450 square root. So plus or minus 21.2 is over 10. And now you split into two problems. So you have negative 14.1 plus 21.2 divided by 10. And you also have negative 14 minus 21.2 over 10. 14, negative 14.1. Plus 21.2, so, and divided by 10. All right, so that's point. Excellent. Oh, wait a second, wait. This is too good. Multiply this by 2, and we get the square root of 2. Oh, yeah. So that's why this is the square root of 2. Now, if you do this side, you get a negative side length. Can you have a negative side length? No! So you don't even have to do it. So you know x is 0.71. So the whole side length is the square root of 2. There you go.